In this video, we're going to take a look at exponential functions and their graphs. Our objective, graph exponential functions and note their basic features. Okay, so what do we know coming in? Well, we know what an exponential function is. It is any function of the form y equals b to the x, where b, which is the base, is greater than 0 and not equal to 1, and x is any real number. Okay, a couple of comments on that. I've already mentioned the first one. The number b is called the base. In an exponential function, the exponent is the variable. So the variable here is in the exponent. That is different than a power function. And then let's take a look at some examples. Well, how about y is equal to 3 to the x? And in this case, the b is equal to 3. How about y is equal to square root of 2 to the x? In this case, the base is the square root of 2. And how about y is equal to 4 to the negative x? And we'll note the base in this case is 4. Okay, so again, we're going to graph these using Desmos, and we're going to take a look at some of the features of these graphs. So let's start off with example 1 here. Graph the exponential function, y equals 2 to the x. I'm going to do it by hand first, and then we'll compare it to the one in Desmos. And generally what I like to do, if I don't have any sense of things, I just go from -3 to +3, for example. So we'll have x be -3, and then -2, and then -1, 0, 1, 2, 3. Why not? Okay, so if x is -3, 2 to the -3rd is 1/8. If x is -2, 2 to the -2 is 1/4. If x is -1, 2 to the -1 is 1/2. Anything to the 0 power is always 1. 2 to the first is 2. 2 squared is 4. And 2 to the third is 8. Okay, so we've got points. We should be able to create a graph from that. I'm not going to be overly fancy. I'll do this one by hand. Do notice that all my y's are positive. So I'll kind of stick to quadrants 1 and 2 in this case. And let's see, x's go from -3 to 3, so I will go from -3 to 0, and then I'll go from 0 to 3. And my y's go from 1/8 all the way up to 8. So I think I'll do this one as 2, 4, 6, and 8. So I'll count this one off by 2's to make it fit on my y-axis. And now let's graph. At -3, the y value is 1/8. Well, that's going to be down here. At -2, it's 1/4, so slightly higher. At -1, it's 1/2, so slightly higher again. At 0, it's 1, so we're here. And then it starts to grow. At 1, we're at 2, so we're here. At 2, the y value is 4, so we're here. And at 3, the y value is 8, so we're here. And if I connect these points, again, perfection eludes me, but you get the general idea. That is the graph of the exponential function y equals 2 to the x. Let's re-notice what we said up here, that an exponential function, your x variable, the x can be any real number. So if we look down here, we'll see that any real number x will have a y value. So I can go all the way down to -1,000,000 to the left or +1,000,000 to the right, and I'm going to have a y value. And let's also look at the fact that all my y's are positive and that my x-axis is an asymptote. as the graph comes down this way, or as we go from right to left in this case, we'll see that the graph gets closer and closer to the x-axis, but it will never touch it. Okay, so let's just see this in Desmos. Get myself straightened out here, I hope. Okay, that looks pretty good, I think. Okay, and again, we can, so in the upper left, we'll do a y is equal to, and this is 2 to the x. So base of 2 raised to the x power, and there is the graph. Okay, and we can see the key point here, it crosses at 0, 1. All exponential functions cross at 0, 1. And you can see it growing rapidly as it goes off to the right. And as it goes down to the left or comes in from the left, the growth is not nearly as dramatic. If I zoom in here, you'll see the graph is always above the x-axis. It just gets really, really close, but it's always above. So there's the graph there of y equals 2 to the x. Okay, let's take a look at another one of these graphs. Another one of these exponential graphs. In this case, we will look at the graph, make sure I'm straightened out here, display the graph of y equals 3 times 1/2 to the x on a calculator and sketch it below. Okay, well, let's see here. So we want to do 3 times 1/2 to the x, so we'll make a note of some of the things we see. So back into the graphing device, Desmos, and to the top right, we need to have y. I'll delete that part. Y equals 3, open parentheses. I got a fraction in here, so I'll do 1/2. There's my fraction. And then I will close the parentheses because that 1/2 was raised to the x power. And so there you have it. Okay, that's coming in. Obviously in this case it's coming in from the left, and then it's going along the x-axis to the right. If we touch on the intercept here is at 0, 3. That's because of the 3 in front. If there were no 3, it'd be 0, 1. But here's the graph coming in, and we'll make a note of that. Plus, if we have any other points we can make a note of. Maybe, maybe not. Trying to find another point that might be nice and round. And I'm not seeing one, so we won't worry about that too much. We'll just make a simple graph of what it looks like. Okay, and straighten myself out. And we noted again that all x's worked and that the output was always positive. So we'll go like this. And we'll simply say, well, this graph crossed at 3. So we'll put a point here. And it came down from up high on the left. It crossed at 3. And then it dropped down. And again, the x-axis became an asymptote. Okay, so there are no y. The y is never a negative value, and any x can go into this. And this is the graph, of course, of y is equal to 3 times 1/2 to the x power. Okay, so let's notice a couple things we want to just make a note of here that we see from these examples. Number 1, the domain, which is the x values, the values that we can put into the function. And those are the x values, the independent values. Okay, so the domain is all values of x. We can put any x in there we want. And we noted that at the beginning that x can be any real number. Okay, also note that the x-axis is an asymptote. Both of those curves got closer and closer to the x-axis as you went further and further either to the right or to the left. And I've got a 3 here, so I'll put a 3 down. As x as x increases, okay, b of x also increases if the base b is larger than 1. Let's go back to the first example. The base of this one over here is 2. And as x is increasing, the graph is also increasing. Okay, so as I'm increasing, going from left to right on the x-axis, the value that comes out of the graph, the y value, is also increasing, and it begins to increase faster and faster and faster. So if the base is greater than 1, as you go left to right, the graph is increasing. As x increases, if the base b of x will decrease, the graph will decrease if b is between 0 and 1. So we're back up to here. Okay, in this case, our base is 1/2. And we'll notice that as we go from left to right, as x is increasing, our graph is decreasing as we go from left to right. And we'll put a little note here to recall. We want to remember that the base is not equal to 1, because there's not a lot of interest in having a base of 1. And of course, the base must be greater than 0. So these are the only two situations. Your base is a fraction, a proper fraction, or your base is greater than 1. Okay? And our next up, we'll take a look at some applications of exponential functions.